So for today's second lesson, we're doing chapter 12, section 5, and that's solving right triangles. And we need to practice our trigonometry. And when we say solving right triangles, what that means is we need to find the missing components. So in a triangle, there are 6 items to look for, 3 angles, 3 sides. We're going to give you some of them, and you have to find the others. So that's the process of solving the triangle. So here's the information we have in example 1. We got triangle ABC. Side A, of course, is opposite angle A, which is 19 degrees, they told us. Side B is opposite angle B, which we don't know what that is. Side C is opposite angle C, and that's 70, and we know angle C is 90 degrees because that's a right angle. So we need to find 2 sides and 1 angle. Those are the 3 pieces we need to look for. They gave us 3 pieces of information. We need to find the other 3. So I would say from here, from 19's point of view, if I put b over 70, that's adjacent over hypotenuse, which is the cosine. And I don't think I have to pull up the calculator anymore, but if I type, first let's get b by itself. If I multiply everything by 70, that gets b by itself. And now I'm going to type in 19 and hit the cosine button. Round that to 4 places so we all get the same answer, so that's 0.9455. Hit the clear button on the calculator, retype 0.9455, and then times 70. That's the length of side B. Now for lengths of sides of triangles, we usually go to the nearest tenth. So 66.185 rounds off to 66.2 approximately. Now we're practicing trigonometry. So I would suggest, even though we know 2 sides, we would not do the Pythagorean theorem to find side A. After all, if you got side B incorrect, then side A would be incorrect also. So there's a greater degree of accuracy here if we do trigonometry again. So from 19's point of view, I'm going to put A over 70, which is opposite over hypotenuse, and opposite over hypotenuse is the sine function. Again, to get A by itself, I'll multiply everything by 70. I'll type in 19, hit the sine button, round that to 4 places. That's 0.3256. Hit the clear button on your calculator. Type 0.3256 again, times 70. Round that actually to 1 place here, so A is 22.8. Now the only thing missing is the remaining angle, which is angle B. And in a triangle, we know that all 3 sides add up to 180. I know some of you say, but wait, it's a right triangle, so A and B have to add up to 90. That's correct also. But in our future episode, we're going to be dealing with triangles that aren't right triangles. So let's add up all the angles together to get 180. Angle A is 19. Angle C is 90. 90 and 19 is 109. Subtract that from 180. And angle B is 71 degrees. So that's the 3 steps we need to solve the triangle 3 parts. Now don't worry, on a test that's not going to be 1 test question. Each part might be 1 test question, so that would be 3 test questions. All right, we got some vocabulary words to look at today, and that's called an angle of elevation and an angle of depression. So let's just get this picture to go with it. If you were in the boat and you looked straight out at the horizon and then looked up at the lighthouse, that angle formed by your line of sight at the horizon and up is called an angle of elevation. The people in the lighthouse looking out at the horizon and then down at the boat, that line of sight would form what's called an angle of depression because we're looking down. So angle of elevation, looking at the horizon, then looking up. Angle of depression, looking at the horizon, then looking down. And a little geometry reminder. Since the horizons are parallel to each other, we have parallel lines cut by a transversal, and that means the alternate interior angles are congruent. So in this case, the angle of depression is the angle of elevation, and sometimes people call these the Z angles because they kind of make, the letter Z and a capital Z. But anyway, these two are going to be congruent to each other, and that'll be useful as we're solving some word problems. Although we won't need it for the first word problem, which is coming up right now. And I'm trying to be more real life situation than most textbooks. So I've added a couple of words to this word problem that textbooks would not say. So here it is. An observer stands on level ground. They're 200 meters from the base of a tower. The angle of elevation to the top of the tower is 26.5 decimal degrees. How high is the tower above the observer's eye level? So here's the picture. Now, most books don't say above the observer's eye level. Most books are willing to have an acceptable margin of error. If you were to read the problem like the book said, you would really have to be laying on the ground for your eyes to be on the ground where the base of the tower is, and then your eyes to look up. So what I'm doing is being more realistic. If you're standing up, your line of sight across the horizon and then up to the top, that's the angle of elevation. That's 26.5 decimal degrees. You're 200 feet away. In my view, and we're not going to do this whole thing, but in real life, if you wanted to know how tall the tower was, once you found this height, then you would have to add the height from where your eyes are above the ground. Or simply you could just lay on the ground and then look up and avoid that situation altogether. All right, but from here, we've got 26 degrees. I want to find the opposite, which we're calling x over the adjacent. Opposite over the adjacent is the tangent function. So that must be who this guy is. He's a tangent. Actually, it looks like he's Mr. Goodwrench. And he's gearing up for this word problem. All right, so actually, no, he's just a Microsoft clip art guy. All right, to find out what x is then, let's multiply both sides by 200. Let's type 26.5, hit the tangent button, round that off to 4 places. Clear the calculator, take 0.4986 times 200, and the answer is 99.72 meters. So multiply that by 3.3 if you want feet. And if you want to be real world exact, then add the distance from your eye level to the ground into that, and that's how tall the tower truly is. And that is all we're going to do for our practical applications of trig and right triangles. In a future episode, we'll have real world applications where it's not a right triangle.